right, here we're going to be talking about comparing and ordering rational numbers. So rational numbers can be fractions, decimals, or percents. We're also going to be talking about real numbers. Basically, we're talking about comparing different things that can be written as decimals, and that's going to be really helpful to write everything as a decimal so that we can actually compare it, because place value tells you everything that you need to know. 9 is bigger than 5, but 0.009 is smaller than 5. It's the same exact number, it's the same digit of 9 versus 5, but the place value, where that 9 is located, where the 5 is located, tells you everything about the number. And that's what we're going to show on these at least the first 3 examples. The place value means everything. I'm going to line these 2 numbers up and then compare them. When I line them up, I want to make sure that the decimal points are lined up, and I want to fill in extra place values. If there is no place value there, I fill those in with zeros. Here it's not that important because you can tell right away you're going to go from left to right. You're looking at each place value one at a time. 0 versus 1, 9 versus 1, 9 versus 0. But actually, we already found out which number is bigger. When you're going from left to right, if you find 1 is bigger than the other, you already found your bigger number. We know that 0 is smaller than 1, so 1.1 is the bigger of those 2 numbers. So that's the smaller of the 2. I'm going to do the exact same thing on set 2. I'm going to change 1/3 into a decimal. That's 0.33 repeating. And 40% as a decimal is 0.40. I'm just comparing one place value at a time. I see that the first place value is a 0 for both. That doesn't tell me any information. Then I have a 3 versus a 4. I know that 3 is smaller than 4, so that is the smaller of those 2 rational numbers. Even though those 3's go on forever, there's a bunch of 3's going on forever there, it looks like that might be a bigger number. We're just comparing one place value at a time. It's a 3 versus a 4. We know that the 40% has to be the bigger number. Same exact thing on the next one. I'm just going to compare these by lining them up. 1.25 times 10 to the negative second. That turns into that decimal. Then 1% is 0.01. I'm going to fill in 2 extra zeros just so I can compare. And then 1 divided by 89 is 0.0112. So I'm just comparing one place value at a time. The first one, the ones place, they tie. They all have zeros. The tens place, they're still all zeros. Still no information. The hundreds place, still no information. They're all ones. So far they're tied. And then in this thousands place, I have a 2, a 0, and a 1. This is the smallest of those 3 numbers because it's a 0 compared to a 1 and a 2 in just this place value. It's the only place value that really matters there when we're comparing these. So 1% is the smallest of those 3. On set 4, we're comparing all integers. There's positives and negative ones, but there are no decimals. I really want to draw a number line for this, just so you get an idea of what that looks like. And I'm just going to draw a general number line. I'm going to put 0 here, 100 here, and negative 100 here. Then I want to think about where positive 10 is and negative 10 is. Positive 10 is going to be on the right side. Negative 10 is here. You can see something weird kind of happens on the left side. When we're talking about negative numbers, the biggest negative is actually farthest to the left. The biggest negative is actually the smallest number. That's actually all I'm looking for. If I'm looking for the smallest number, I'm looking for the biggest negative. That's negative 10. It can't be any of the positives. And negative 10 is a bigger negative number. It has a greater absolute value than negative 3, making it the smaller number. So whenever we're trying to compare numbers, we always want to write the numbers as decimals and then compare each place value. And we always line it up by the decimal. We also want to consider a number line when we're thinking about positives and negatives. the larger or bigger absolute value, the greater absolute value, or distance from 0, when we're talking about negative numbers, actually that is the smallest number. Negative 10 is smaller than negative 1 because it's farther to the left on the number. It has a lesser value. It's like if you owe somebody $100 versus owing somebody $10, you'd much rather owe them $10. You have more, really, you have actually more money when you just owe them $10. And that's exactly the point we're going to make on this number line. So you see those are equally spaced out, and it starts at 0 and 1. So those are positive numbers going that way. So we're really just going to count by 1 going to the left, negative 1, negative 2, negative 3, negative 4, then we have negative 5, and we'll fill in negative 6. Next one's a little bit trickier because we have decimals. So we see that on the right side of this, 1.0, 1.2, it's going up by 0.2 each time. So I'm just going to use that logic going backwards. I'm going to go down by 0.2. So from this to that, it would have to be adding plus 0.2. So going backwards, it would turn into 0.8. You could also think of that as 1 minus 0.02. And really, I'm just going to keep counting backwards. It's going to be all the even digits here. 0.6, 0.4, 0.2. Then we have 0. And we're going to go one more step back into the negatives, negative 0.02. On the last one, we can see, I'm going to actually count from 0 here. Going that way, it's subtracting 0.1. So we're just going to keep counting by 1/10 going backwards. That makes that 0.02, negative 0.03, negative 0.04, negative 0.05, and we have negative 0.06 filled in already, and negative 0.07. As you go to the left on the number line, the numbers actually get smaller. They appear bigger, but the bigger negative number is actually the lesser value. On these, I'm just going to go through the left side, and I'm going to have you do the right side on your right. So this is similar to something on the front. We're trying to compare which of these numbers are smaller, but now we're dealing with negative percentages. I'm going to change those into decimals first. That's negative 0.30 versus negative 0.03. The bigger absolute value is that. That one appears bigger. But we're dealing with negative numbers. It's the bigger negative number, which actually means it's the smaller value. That is the smaller of the two. On number 3, we're trying to put one of those symbols in between these. So less than, greater than, or equal to, so that we can compare these two numbers. It's actually the same thing that we just did, except now we're using an inequality or equation set. So I'm going to stack these two on top of each other, negative 0.021. So the one that I put on the bottom is the smaller number because it's the bigger negative. It's smaller, and when we write inequality signs, the arrow is going to point towards the smaller number. Negative 0.02 is greater than negative 0.021. On number 5, we're trying to shade everything that's in between those two values. I want to think about this on a number line. I'm going to place both of those on a number line. Negative 420% is really negative 4.2. Negative 5.5 times 10 to the 0. If that 0 means I don't move the decimal place at all, it's actually just negative 5.5. If you forget your scientific notation rules, you can always just multiply that out. That's really just a multiplication problem. It's saying negative 5.5 times 10 to the 0th power. You're allowed to just multiply those. Now I'm going to place those on a number line. I want to put 0 on there just so I have a point of reference, the smaller number is that negative 5.5. I'm going to put that farther to the left. And then negative 4.2 is somewhere in between these. My first decimal is negative 6.25. That is a bigger negative than negative 5.5. That would end up somewhere over here. That's going to end up to the left, which is not what I want. I'm looking for something that's in between. Something in between those two on the number line. So that does not work. 21 divided by negative 4 is negative 5.25. Negative 5.25. If I compare that to negative 5. I'm actually going to add a decimal place here. Negative 5.0. It's a smaller negative number than negative 5.0. But it's a bigger negative number than negative 4.2. Which is exactly what I'm looking for. That's going to end up closer to the left side there, but that is going to end up in between there. So that's one that will fall in between those on a number line. The third one, that 10 to the second power is telling me to move the decimal place 2 spots to the right. That's going to end up as negative 4.9. That's a bigger negative number than negative 4.2. But smaller than negative 5.5. That'll also end up somewhere in there. Actually, I'm going to line those up just so you can see that clear. Negative 4.9 versus negative 5.5. This is going to be farther to the right. It's the smaller negative number. But the opposite is true when we compare it with negative 4.2. Negative 4.2 is farther to the right. So it's going to be somewhere in between that, and then it's bigger than negative 5.5, but smaller than negative 4.2. The next one, actually I can rule that out right away. It's a positive number. It's 4.9 as a decimal, but it's positive. It's not going to end up anywhere on this side of the number line. It's going to be somewhere way over there. I can rule that one out. Negative 0.45. That's actually going to be very close to 0. We're dealing with whole numbers here. This is going to be somewhere very close to 0. It is a negative number, so it's still going to end up on that side. But it's somewhere very close to 0 compared to these whole number parts of these other numbers. The negative square root of 22 is actually negative 4.69, which actually also will fall directly in between those. Actually, it's really close to this. I can change that to 4.69, and you can see that the same thing is true. It's still bigger than negative 5.5 and smaller than negative 4.2. So that will end up a little bit to the right of that. All right, a number set. We're going to order these from least to greatest, greatest to least. If the set below is ordered from greatest to least, which would be second? So we're going to order them from greatest to least first. I'm going to change everything into a decimal as my first step. So the last one's already decimal, so I don't have to change that at all, but I changed the first 4 into decimals. And now I'm going to stack them on top of each other, just so I can compare them easily. Maybe I don't actually need to do all of that work, though. So I'm talking about greatest to least, and I'm looking for the second number. The greatest numbers on this list are going to be the positive ones. There's 3 positive numbers. I know I'm not even going to get into the negative numbers. I'm looking for the second number on the list. I'm looking for the second one when we're going from greatest to least. It has to be a positive number. I actually can ignore these negative numbers on this one. They have to be at the end of the list. They're the smallest of the numbers. So I'm going to actually cross those out right away and just compare my positives. 0.7 0.6 repeating, and 0.66. I'm looking for which one would be second. Basically, which one's the second biggest? So I have a 0.7, that's the biggest one. I'm just looking at that place value. 0.7 is bigger than either of the 0.6s. So I can rule that one out. That's going to be my first one. Actually, this is going to end up being in order already. I have a 0 here. This place value tells me what I need to know. That middle one will be my second number. This would be my third. And then the negative numbers would come up. But that's not what the question's asking. It's just for the second number. So 2/3 is the second number when that list is ordered from greatest to least. All right, the last one I'm going to do with you, we're going to try to place all of those numbers on the number line. So this is basically just comparing and ordering, but they're giving you a number line to just plot these points on. First step is going to be the same. I'm going to just change all of these into decimals in my first step. Now that they're all decimals, make sure that you're actually able to convert those into decimals. If you can't do that, the next step is going to be impossible. Now that they're all decimals, I'm just going to try to drop those in. I'm going to start with the easiest one. C is 1. I'm just going to put that right where it's supposed to go, on top of 1. I guess I'll go in order from there. So negative 1.25 for A. Negative 1 is really like negative 1.00. Negative 1.25 is a bigger negative, which means it has to be farther to the left. It's actually going to be in between these two. This is negative 1.5, or negative 1.50. It's halfway in between those. It's like $1 and $1.50. Directly in between those is $1.25. These two numbers just happen to be negative. B is negative 2.6, so it's farther to the left than negative 2. You know it's going to be that way. I know that this is negative 2.5. Actually, it's going to be even farther to the left from that, just slightly to the left of that. Letter D is 0.032. That is a very small decimal. So if I compare that, let's say I compare that to 0.5. I'm going to look at the first two decimal places here. I'm going to compare these two. Just to give you a comparison in your head, it's really like comparing the number 3 to the number 50. It's much smaller. 3 is much closer to 0 than 50. So that's going to end up being right next to 0 there. And our last one is 0.9. That's just smaller than 1. It's like comparing $1 versus 90 cents. 90 cents is just a little bit less than $1. So E is going to go just to the left of C.